Okay, this video I'm going to show you how to do those additional study guide problems, and then I'm going to have you look for the message to show me that you've watched this video. So here I go. Where is play? So for this, my example I did already, I have right here a square that has all equal sides. Square has negative reciprocal slope on these slopes. My next shape, first thing I'm going to do is plot it. So plot it just so you have an idea of what you're looking at and let the work dictate what you're looking for here. So I'm going to plot A, which is negative 1, 1. I'm plotting B, which is 0, 5. C is over 4 up 6, and then D is over 3 up 2. So X first, Y second. Make sure you know how to plot coordinates. If I connect those, it shows me that that is a rhombus. A rhombus will have all equal sides, and the slopes will just be a flip-flop. They won't be negative flip-flop like this square here. They'll just be reciprocal. So my proof that this is a rhombus, I'm going to do the distance formula 4 times.
First side. So A between negative 1 and 0, subtracting negative 1 minus 0 squared plus 1 take away 5 squared. No double negatives there. So negative 1 squared plus 1 minus 5, which is negative 4 squared, gives me the square root of 1 plus 16, which is the square root of 17. So that is the length of A and B. Finding the length of B and C using these two coordinates. So 0 take away 4, subtract the two X coordinates, plus 5 take away 6, subtracting the two Y coordinates, gives me negative 4 squared, which will be positive 16, plus 5 minus 6, which is negative 1 squared. That gives me the square root of 16 plus 1, which is the square root of 17. So far so good. Two lengths are equal. Find that third length, CD. So that goes from 4, 6, 3, 2. So 4 minus 3, subtract the two X coordinates, plus 6 minus 2 squared. Subtract the two Y coordinates, gives me 1 squared plus 4 squared, which is 1 plus 16, which is the square root of 17. So far so good. Three lengths are the same. Next, AD, that will be from negative 1 subtracting 3 squared, plus 1 take away 2 squared. 1, negative 1, and negative 3 combine to give me negative 4 squared. 1 minus 2 is negative 1 squared. So that gives me the square root of 16 plus 1, which is the square root of 17. So all 4 lengths are the same. The only difference between this one and the square slope's negative reciprocal. These rhombus slopes should just be regular reciprocal, not opposite. So the formula again that you need to be good at for this test is the distance formula, which is x2 minus x1, or just make sure you subtract the two X coordinates, plus y2 minus y1. Again, make sure you subtract the Y coordinates. Slope, a little bit more technical because you need to make sure you subtract in the same direction for both X and Y, and you subtract those Y's way up high on top to get your rise. So slope is rise over 1. So here are my slopes. Between A and B, I have 1 take away 5. I'm subtracting left to right, subtracting the Y coordinates, 1 minus 5 on top, over negative 1 minus 0,
1 minus 5 is negative 4. Negative 1 minus 0 is negative 1. That simplifies into positive 4 over 1. We never write these two negatives right here in algebra. BC. Top will be the y-coordinates 5 minus 6 over 0 minus 4. It gives me 5 minus 6, negative 1. 0 minus 4 is negative 4. That also simplifies to positive 1/4. CD will give me 6 minus 2 on top over 4 minus 3. That gives me 4 over 1. And then the last slope, AD, will give me 1 minus 2, subtracting the y-coordinates on top, over negative 1 minus 3. And that gives me negative 1 over negative 4. That also simplifies to 1/4. So my proof shows this. All my lengths are equal, just like a square. But a square, doing those slopes correctly, I have 3 over 2, and the other slope is 2 over negative 3. That is a negative reciprocal. One is positive, one is negative, and they're flip-flopping. For this rhombus, my slopes are not opposite. They're both positive, but they are reciprocal. That's what happens with a rhombus. So one slope here is 4 over 1. This is 1/4. This slope is 4 over 1. This top slope is 1/4. That shows just a reciprocal. That proves it is a rhombus. Here is the first letter, first word in the phrase I need you to show me tomorrow. So there it is. All right, next page. This one, I need to find the area and perimeter. I have straight sections, so do not use the distance formula to find these horizontal or vertical sections. So BC, counting boxes, 1, 2, 3, is 6 boxes long. AD is also 6 boxes long. BE is 4 boxes long. And then my other lengths, A, B, and CD, I need to use the distance formula for those. So listing out all my coordinates, A, B, C, and D. A is negative 3, negative 1. B is negative 2, 3. C is 4, 3. And then D is 3, negative 1. Make sure you're writing the coordinates accurately. So to find that distance between A and B, I'm going to subtract the two x coordinates, negative 3, subtracting a negative 2, that is a double negative, that turns to plus. Negative 3 subtracting negative 2 is negative 3 plus 2 squared. Negative 1 minus 3, no double negatives there. That gives me negative 1 squared plus negative 4 squared, which is the square root of 1 plus 16, which is the square root of 17. That is that length of AB right there. To find CD, that is the square root of C, 4 minus 3 squared, plus 3 minus 1 turns to 3 plus 1 squared. Gives me 1 squared plus 4 squared, which is the square root of 1 plus 16, which is the square root of 17. So my lengths, I have 6 down here, 6 on top, root 17, and then by mistake here I write 3 at first, but I will change that to a 4, I promise. So perimeter, adding all the edge sides together is perimeter. So 6 plus another 6 plus root 17 plus root 17 gives me 12 plus root 17. 2 of them gives me 2 root 17. If I do that accurately on my calculator, 12 plus second square root button 2 root 17 gives me 20 0.2462. I'm rounding to 2 decimal places right here. So I look at the indicator number to the right. That is 5 or more. So that number I'm rounding to goes up by 1. That gives me 20.25. Area is base times a vertical height. Don't use that slanted length as the height. Base times height. Do not cut this in half. This is not a triangle. So putting that correct height in there, that gives me 4. So this area is 6 times 4, and then I am done. 24. Just remember, a triangle has you multiply a base times a vertical height. So root 40 times root 10 for that first example. And then you divide that in 2. You do that for a triangle. But this one does not. This one's a rhombus, or I'm sorry, this is a parallelogram, which is just base times height. Alright, the next word in the phrase I'm looking for are right there. There it is. Alright, next page. This one, function transformations, I'm going to have you graph that first function first, f of x. That is -5. That is my y-intercept. So I'm going to go down to -5 on the y-axis. And then after I get that first point, -5 on the y-axis, I then look at 2/3, my rise over run, which shows me a run of 3, a rise of 2. So my first point, 0, -5 goes right here. Now looking at the number in front of x, which is my slope or my rate of change, that is 2/3. So that means from -5, every time I run 3, I go up 2. Over 3, up 2. Draw my line through it. Label it f of x equals 2/3 x minus 5. My transformation equation, this g of x, shows me I'm taking that line and moving it up 7 boxes on the y-axis. So whatever that number is tells me how much to move it up, or if it's negative, how much to move it down. That is the new y-intercept. Same exact slope of over 3 up 2. That is the g of x line. To get full credit tomorrow, I want to see you substitute one function into the other to simplify it to get the equation of that second line. So f of x equals 2/3 x. So 2/3x minus 5. G of x is f of x plus 7. So I'm going to take that 2/3 x minus 5 and I'm going to substitute it right in here into the other equation, f of x. So where that f of x is, I'm going to replace it with 2x minus 5. So I get g of x equals 2/3 x minus 5, where that f of x used to be. I still have that plus 7. And these two terms are going to combine to give me positive 2. So my new line is g of x equals 2/3 x plus 2. And I'm going to label that up there. Alright, here we go. Next word in the phrase. And then my last page. Alright, congruent triangles. So these examples show, first one, a side angle and a side, an angle sandwiched between two sides. Side and angle, side. Look at them right in a row. 1, 2, 3. Side, angle, side. This one is side, side, side. Number 3, an angle with a side sandwiched between another angle. And again, start somewhere, follow kind of a clockwise pattern. Angle, side, angle. This one is angle, angle side. So know your congruent triangle postulates. This one is angle side side. That is not good. You cannot have that along with A, angle, angle, angle. Not congruent. These examples up here. First one, starting and going in clockwise pattern, is angle, side angle, a side sandwich between two angles. Since they are congruent now, I could go ahead and compare these two lengths. This has got to be 40. So for that side to be 40, x has to be 10, solving that algebraically. This one is side, angle, side. So again, now they're congruent. I could compare these lengths. If this is 50, x is 50. Number 3, this is side, side, side. So I know these two sides are equal. I could set those equal to each other. 4x plus 1 equals 2x plus 7. To solve that, take away 1 on both sides, bring down that 4x, bring down the 2x plus 6, subtract 2x on both sides, and that gives me 2x equals 6. Divide by 2, and that shows me x has to be 3. That is not that length. If I took that 3 and plugged it in there, that would give me the actual length. So 4 times 3 plus 1 gives me 12 plus 1, which is 13. Same as if I took that 3 and put it right here, 2 times 3, 6 plus 7. Those two lengths are 13. The last one, this is angle, angle, side. 2 angles in a row and a side. And I did not give you anything to compare there. Next word in the phrase I believe is coming. There is the last part. I am also wanting you to show me on paper, other than the phrase I just had you write, I want you to show me the formulas for circles for practice. So make sure you know your circles. So for a circle, if I had a radius of root 6, area is pi r squared. So if I plug in the radius in that r right there, it gives me pi times root 6 times root 6, which is the square root of 36, which gives me just plain old 6. Anytime you square something square rooted, those cancel and leave you just the number out front. If I type that in my calculator, 6 times the pi symbol gives me 18.85 rounded. Circumference is 2 pi r. Plug in that radius is root 6. Multiply that 2 and root 6 together and then times pi. That gives me the perimeter, the circumference of that circle. Alright, so again, to prove to me that you watched this video on a piece of paper, write the phrase that I showed you, and then write this circle area and circumference for practice. I want to see that. That will be proof that you watched my video. Good luck.